I'm Franck, and I'm a senior. I'm presenting my research on prairie burns. There are three factors that create and maintain prairies. Those three things are fire, grazing, mammals, and drought. Grazing mammals and drought. These things all work together to prevent the establishment of woody species of plants like trees and shrubs. Prairie fires in particular act as a major ecological force by helping to create a higher biodiversity of plant species in that ecosystem. Historically, prairie burns have been done at all times of the year, but today prairie burns are typically done in the spring. Ranchers need prairie burns to help improve the health of their grazing livestock. Having healthy new plant growth from the burns helps keep the forage nutritious for livestock. In a 3 or less year cycle, the Flint Hills in Kansas has roughly 3 million acres burned, which is about half of the entire prairie. Research is needed to determine if spring burning is warranted or if burning could also occur at other times throughout the year and still maintain ample plant biomass. Studies examining the effects of the various times of burn on prairie plants show different patterns. Some studies have shown that burns done in the late winter through mid-spring produce a low forage yield, telling us that winter and early spring burns should not be favored. Other studies come to conclude that warm season grasses do better when the burning is done in late spring, but it leads to less species richness. All other studies have shown that fall and early winter burns actually help grass survive periods of drought later on in the summer, which can lead to an increase in plant production, telling us that incorporating fall-winter burns would be beneficial. It also has been found that annual spring-summer burns increase the amount of C4 gramineal grasses and annual fall burns increase the amount of forbs grass. For this study, I wanted to investigate the effects of annual burning of prairies at various times of the year and see how changing the burn time can affect plant composition and biomass. I utilized a publicly available long-term data set from the Flint Hills of Kansas, a natural tallgrass prairie. I used the data collected by the Konza Prairie Long-Term Ecological Research Program and analyzed it in Excel. Biomass was separated into 4 categories: forbs, woody, live, and dead. Clippings collected were dried, sorted, had all debris removed, re-dried, and then weighed. Over the 21 years, 7,920 vegetation samples were collected. After looking at all the data, we found that lowland areas had more living grass than upland areas. If you look at Figure 1, you can see that summer had the lowest amount of living grass compared to winter, spring, or fall. In Figure 2, we see that the greatest number of forbs was on the fall burn, followed by winter, summer, and then spring. Forbs were generally more abundant in lowland areas with the exception of summer burns, which had fewer forbs. In Figure 3, we see woody vegetation did not relate to burn season or their interaction. And in Figure 4, we see that overall biomass was affected by burn season, but not by location or interaction. Winter, spring, and fall burns had the highest biomass, and summer was the lowest. After looking at the trends in the data, we can conclude that prairie burns done in the fall, winter, or spring will be beneficial to the prairie, and summer burns should be avoided. This is due to the summer burns having the overall lowest biomass, along with the highest amount of woody species biomass. The fall, winter, and spring burns show a decrease in woody species and an increase in living grass biomass. Fall and winter burns should be more favored due to showing increased biomass of forbs. So in conclusion, prairie burns are most beneficial when done in the fall and winter seasons of the year if your goal is to increase grassy species and limit the amount of woody plant species. If I were to do the study again, I would include the effects of grazing mammals with the data collection. Cattle grazing can affect overall plant species, basal cover of plant species, and plant diversity compared to non-grazed prairie. Thank you for listening.